Welcome to School Page Video Teacher. Tenth CBSE Physics Chapter The Human Eye and the Colorful World. After watching this video, you will be able to understand Tyndall effect, why is the color of the clear sky blue, and also understand why the color of the sun at sunrise and sunset is red in color. Blue color of the sky, color of water in the deep sea, red color of the sun at sunrise and sunset are some of the wonderful phenomena of scattering of light. So let us study all these phenomena in detail. Scattering of light. We need to understand few concepts to study scattering of light. We should know what is a homogeneous mixture, heterogeneous mixture, and colloidal solution. A homogeneous mixture is a mixture where the components that make the mixture are uniformly distributed throughout the mixture. For example, sugar water and salt water. So when you mix the sugar or salt in the water, it gets dissolved completely. You may not see the sugar or salt particles lying in the water. Whereas heterogeneous mixture is a mixture where the components of the mixture are not uniform. Example, sand water, oil and water. So the moment you mix sand in water, you may notice that the color of the water would have changed and the sand particles would have settled at the bottom. So here when the oil is mixed with water, the oil floats on top of the water. So in this case, you can easily separate both water and oil. So let's move on to understand what is a colloidal solution. Some mixtures look homogeneous, but they are actually heterogeneous. So such mixture is called as colloidal solution. Example, milk, blood, etc. So when you look at milk or blood through the naked eyes, you may notice that the components are uniformly distributed throughout the mixture. But when you look at these solution through a microscope, you may notice that the components of the mixture are not uniformly distributed. So such solution which look homogeneous but are actually heterogeneous mixture are known as colloidal solution. Atmosphere is a mixture of minute particles. So when a beam of light strikes these particles, the different color of light waves get separated and travel in different directions. This phenomena is known as scattering of light. So when a beam of light strikes these particles, the different color of the waves get separated and travel in different directions. This phenomena is called as scattering of light. So now let's move on and understand what is Tyndall effect. Since we know what are colloidal particles, it is easy for us to understand Tyndall effect. We know that Earth's atmosphere is a heterogeneous mixture of minute particles. These particles include smoke, tiny water drops, droplets, suspended particles, of dust, and molecules of air. So when a beam of light strikes such fine particles, the path of beam becomes visible. The light reaches after being reflected diffusely by these particles. The phenomena of scattering of light by the colloidal particles gives rise to Tyndall effect. So let's understand Tyndall effect in detail. In this picture, you may observe when sunlight is passing through a canopy of a dense forest, the tiny water droplets in the mist scatter light. So can you see how sunlight is got scattered everywhere? This is called as Tyndall effect. When you look at this, there are two glasses filled with water. So this is a clear solution which is water. Whereas this solution is a colloidal solution because few drops of milk is added to this water so that it is called as colloidal solution. You may also notice the change in color. So when you try to pass light through these solutions, you may not see scattering of light in this solution and you can see scattering of light only in colloidal solution. True solution cannot scatter light because of their small particles. Whereas colloidal solution scatter light making a beam visible, so you can see a beam of light visible here due to their large particle size. So scattering of light by the colloidal particles is called as Tyndall effect. So now let's understand another phenomena of scattering of light, which is why is the color of the clear sky blue? So what is the reason for the sky to appear blue? When sunlight passes through the atmosphere, most of the longer wavelength such as red, orange and yellow do not scatter much by the air molecules and hence they pass straight. Whereas the shorter wavelength such as for blue, light is scattered all around the sky by the air molecules in the atmosphere. Hence the sky appears blue because the molecules in the air scatter blue part of the sunlight much more than they scatter red light. You might have also observed that danger signal lights are red in color. Do you know why? Since the red color is least scattered by fog or smoke, it can be seen in the same color at a long distance. Hence, danger signal lights are always red in color. Now let's move on to another interesting phenomena of scattering of light to understand why the sun appears red at sunrise and sunset. So this is the view of sun at sunrise and this is the view of the sun at sunset. At the time of sunrise and sunset, when the sun is near the horizon, the sunlight has to travel the greatest distance through the atmosphere to reach us. During this long journey of sunlight, most of the shorter wavelength, that is the blue color, present in it is scattered out and away from our line of sight. So the light reaching us directly from the rising sun and the setting sun consist mainly of longer wavelengths, which is red color, due to which the sun appears red. This figure gives us the clear understanding of reddening of the sun at sunrise and sunset. This is the earth and the person is standing here. The light from the sun near the horizon passes through thicker layers of air and larger distances in the earth's atmosphere before reaching our eyes. So what happens here? Blue light is scattered away and hence the sun appears reddish at sunrise and sunset when the sun is near the horizon. So let's see what happens when sun is nearly overhead, that is during noon. The light from the sun when the sun is nearly overhead would travel relatively shorter distance, hence at noon the sun appears white as only a little of the blue and violet colors are scattered. So now you should have understood why does the sun appear red at sunrise and sunset and does not appear red when it is overhead. After watching this video, you should have understood what is a Tyndall effect, why is the color of the clear sky blue, and understand the concept of reddening of the sun at sunrise and sunset. Thank you for watching. For more videos, visit our website videoteacher.schoolpage.me.